I was in the process of transferring a circuit from one of these little prototyping boards to a little more permanent printed circuit board configuration when it occurred to me that a number of questions that viewers have asked over the last several months I've never answered. I keep wanting to accumulate enough of them to kind of do an overall video, so that's what this video is going to be about. It's about prototyping, and there are others who have done videos similar to this. One excellent one by Alan, W2AEW, that I refer you to. In fact, this one is going to duplicate some of what he talks about. But the circuit that I'm actually transferring is this one that some of you may remember from the class AB amplifier and feedback and so on videos. It's a circuit that I've used over and over again as a demonstration circuit, and I had it built up on one of these little perf prototyping boards. There are some downsides to that we'll talk about in a minute, and I use the circuit so often that I wanted to make a permanent version of it, and I do this from time to time. When a circuit is proving to be very useful over and over and over again, I will often switch it over to a PCB, and you'll see one down here that is also a fairly recent. This is the step generator that I built recently. But at any rate, one reason to transfer to the PCB is because it makes it a little more permanent, and also, quite frankly, it frees up the breadboard for other things. The up in the upper corner here, and one reason that I was doing this is I saw a video by Andrew Spieth the other day in which he was talking about he had gotten some really good breadboards. So I got some of the same ones that he got, and I agree with him. They're pretty good. Most people have a lot of bad luck with these because there are some cheap ones. We'll talk about that as we get a little further along. But before I get very far along, let me talk a little bit about this circuit. Now, you may notice that this circuit is built on a board. I'll turn it so that you can see. This is what is called island construction. In other words, what you do is you cut the foil of a PCB, in this case it's a copper PCB, so that the island is separated from the rest of the copper, and then you use that to attach the leads of devices. This particular one was a mixer, that dual gate FET mixer that I was working on actually more than a year ago. Eventually I wound up actually just building the circuit onto a board, but I had started out prototyping it with this, and I only got about this far when I realized that I had messed up and I had put some of these in the wrong place. So one of the things that prototyping will teach you is you do have to plan ahead. Just because you can change things later doesn't mean that you don't have to plan ahead a little better. So let me talk a little bit about this technique, because when you get to higher frequencies, this technique is far superior to the breadboards that you see here, including the PCBs. And the reason is that it has this nice ground plane that gives you a more controlled situation. I'm not going to get into that too much, but as I've said, Alan, W2AEW, has built a number of devices on using this island construction. So I'm not going to talk very much more about that, but I will, to sort of finish up this section, talk a little bit about the tools you need, and then refer you to his video for more details. Here are some of the drills that you can use to make those little islands. Let me show you once again what we're talking about there. I'm talking about these little circles that are insulated from the rest of the copper. Now, you can buy these diamond core bits. They generally, jewelers use these, and they go under different names. There is a place that sells these. It's called QRP Me, that sells a variety of kits that are built using these sorts of techniques, and they also sell these. But you can find them on eBay or other places. A lot of jewelers use these to cut stone for what they call beads or jewels to put in jewelry. So you may find them under a jewelry website, which is where I bought these. Okay, so we've talked about the island technique. Now I'm going to focus almost exclusively on these proto boards, but we'll talk about these printed circuit boards also, because you will find that there are times that, due to limitations in these, or because you just want a more permanent version of the circuit, that you'll want to transfer from this to this, or in some cases, like this little generator, step generator, you might just build it that way to begin with. So let me get some of this out of the way and talk about some of these boards. But before I do, let me just point out that you can get these boards in a variety of sizes. They make small ones like this, medium-sized ones. This is an 830, I think. These are 400 or so pins. These are about 800. And then they make the big boards like this. And in general, what I have found is that price doesn't guarantee quality. However, if you buy the cheapest thing you can find, you pretty much are going to get bad quality, unless, like in this case, you have a situation where somebody has found something that's especially good at a very low price. These were very, very cheap. They are made by Elego. Let's see if I can. ELEGOO. So you might look for those. I don't know if they're still going to be available or not. But before we get a little deeper into the prototyping using these boards and the transferring of those to printed circuit boards, let's take a little bit of a look at where we're going and why. So here is a little outline I prepared for my own organization about things that you might want to consider: the frequency or rise time of the circuit that you're working with, how much power it's going to take, and by the way, this can be very important. In some cases, you may need to provide heat sinks or cooling of some kind and so on. In general, these little boards, prototyping boards, are not satisfactory for very high power, things like AC, switching, and so on. But for small audio amplifiers and so on, it's perfectly okay. Or even for a higher power amplifier that you don't drive to its limits. In other words, you prototype it at low power, and then you transfer it to a system that can handle higher power. Another thing is the complexity of the circuit, because as we'll see in a minute, some of these breadboards adapt to a complex circuit, but in general, if you have a very complex circuit, you probably should use a bigger breadboard, because you'll find that it spreads out pretty quickly. Then flexibility. Obviously, a PCB with soldered connections is less flexible than one of these prototyping boards with plug-in jumpers. And that also goes to the question of permanence. A PCB will be more permanent, and so therefore you're less likely to have problems with connections coming loose and things like that. Now, as I've said, there are different options. You can use these prototype breadboards. You can use the island layout that we talked about a little bit ago. You can use what are called universal PCBs, and then you can use what are called prototype PCBs, and we'll talk about those when we come back to the PCB part. So here are the basic issues, at least in my mind, of what you need to think about. The interconnect, and by that we don't just mean interconnect in the circuit itself, but interconnect between the circuit and your test equipment, your power supplies, etc. Usually you can get away with jumpers, that is, jumper wires that plug in. Sometimes, though, you really are better off by soldering things. And so that's one reason that you might want to go to a PCB first, like I did with that little step generator. The next is access. And access, a PCB will give you access, but part of the problem is that the circuit is on the bottom. And some of the connections are the components are on the top. Now, some of the connections you can get to from the top, but some you can only get to from the bottom. Whereas, if you're using one of these prototyping boards, you can get access. Everything is on the top. In fact, there's no connections that you can get to easily on the bottom. So that might be a consideration as well. And as we talked about, you also need electrical access. In other words, you need to be able to attach test equipment and other things. And finally, you need to be able to make changes. Now, obviously, making a change on a board like this is harder than on a prototyping board like this one. Okay, enough about that. Now let's focus just on these boards and talk a little bit about what to look for and the accessories you might want to buy when equipping a lab for this kind of prototyping. This is an old prototyping board that goes back, I think, into the 1980s perhaps, and maybe before. It's pretty good quality. And by that I mean the contacts that are in here tend to take wires pretty easily. They tend to make good contact with those wires, and they tend to last over time. That is, you can plug and unplug parts and jumpers and so on without wearing them out. But let me show you what I have found with regard to these things in terms of their quality and the way they're constructed. Some of them are constructed by simply putting two pieces of metal like this, and here we're looking at, let me zoom in a little bit on that one. We're looking at the board being like here, and you have to get a wire between those two. Well, part of the problem is that when you push a wire down and it's just the two tips are like that, it actually tends to squeeze them together. So they're very hard to get in. A little better system is where they make the ends flare out a little bit like that, so that when you put the wire in, you get you tend to spread the connector as you insert the wire. Still better is the technique that is used on this board, which is looks like a tulip. If you know what a tulip blossom looks like, it forms a kind of cup. Let me zoom out where you can see my hand a little bit, like this. In other words, it's not just two pieces coming together here. It's two pieces where one side forms a cup like this, and the other side forms a cup over here. That's the way that these boards are made, and frankly, inserting components into these boards is a breeze compared to some of the cheap boards like this. These I bought some years ago, and frankly, they're pretty hard to use. The last thing before we look at accessories is you might want to consider getting a board that has connections for power supplies here. But remember, you still have to connect between these connections and the board itself. Usually there will be a row or sometimes two rows of power connectors where all of these are connected together, that is the red ones. All the blue ones are connected together. So for example, you might put a positive supply on the red and a negative supply on the blue, or ground on blue, whatever you choose to do. But just remember that you do need a way to interconnect to your power supplies. And then this is an interconnect board that you may have seen in an earlier video that is made by Digilent for their analog discovery, that allows you to plug their analog discovery into these prototyping boards. And actually, by the way, this board is also made by Digilent. Once again, I don't have any connection with any manufacturers or suppliers or anything. I'm just a user. So, at any rate, those are a few things you might think about. Now let's talk about the interconnect options. Here are some interconnect options. At the bottom, you'll see a box with some jumpers of various sizes. These are very small and these are much larger. I'll show you one here in a second that has some intermediate sizes. And you can buy these in kits. It's kind of neat to do that. It's a real bother to have to go through and cut and strip all these wires. And so they're cheap enough that most people just buy them pre-cut like this. An alternative is to buy a set of multicolored wires like this and cut your own. These are a little bit longer wires, and you can either use them as they are, or you can cut them to shorter lengths and strip them. And then finally, you have jumpers that are a little more organized. These, some of them will come with a male connector on the end. Some of them come with a female on the end. You may notice this one has a male on one end and a female on the other. You can also get wires that have connectors pre-installed, and if you're working with any of the little modules that work with Arduinos and Raspberry Pis and so on, it's very useful to have these, because this will just plug straight in to the module, and then you can hook these to your breadboard. Depending on how the module is configured, you may find that that's a whole lot easier to do. And of course, you can get a variety of sizes. Generally, the smallest ones that are pre-made are about this long, and you can get them up to, well, you saw a box earlier that has extremely long jumpers in it. I said that I would show you another box. Hold on just a second and I'll go get that. Here is a box of jumpers of varying sizes. You'll notice that there are two sizes in this compartment, the brown and white, two sizes in here, a purple and a gray. I guess there's a white one that got mixed in there by mistake. I'll put it where it belongs. Whoops. Well, let me take care of that later. And slightly smaller, and they get down to these real small ones that are so short that they don't even have any insulation on them. So those are some of the options for that. If you are making connections and you're using things like the female connections. What you might want to do is get some of these pins that you can buy, and these are also designed to be used on boards like Arduino and Raspberry Pi. They come in two different styles. One style is this one with the, let me see if I can get it where you can see it better, with one end much longer than the other. Now, quite frankly, you can actually adjust that. If you push on it hard enough, you can slide it through and it'll adjust to whatever length you want. But basically, there's this size, and then there's a size that is the length of the long side on both sides. And those can often be easier to work with, because if you try to push these into a prototyping board, sometimes they aren't long enough to make good contact. On the other hand, if you use this side in the board, then these will be too short to hook connectors to. So you might want to get a variety of these, because these are actually designed to be the shorter ones. The ones with short on one side, long on the other, are designed to be soldered into printed circuit boards like Arduino hats and things like that. Okay, enough about those kinds of prototyping. Now let's talk about printed circuit boards. Now suppose that you're either decided to transfer a circuit from one of these plug boards to a PCB, or you just wanted to build it on a PCB to begin with. Well, what are the available options? Well, one of the good options, if you're doing a transfer, is to buy one of these kinds of boards. This is a, see if I can get a little more light on that. Is called an SB830 solderable PC breadboard, or bread. And I got these because if you notice the arrangement, the plating, the copper plating, it duplicates the layout of these boards. That is, you have 2 rows of power at the top, 2 rows of power at the bottom. Actually, it looks like these have 3 rows. Well, that's even more convenient. And then in between, you have the layout that you see in the normal board, where you can plug a dip socket across the middle here, or you can plug in things like this 741 op amp and so on. And of course, the component sits on the other side here, and this one is kind of nice because it shows the layout. It's got a silk screen on this side that shows the layout. So those are one option. Another option is some boards that I got from GeekFun. And these are called GeekFun large solder kit for Arduino CK100R. These are very much the same thing. In this case, it's only 2 power, and they don't have the extra set of connectors in between the bridge here. But basically, these are identical to these. So those are good alternatives for that kind of thing. If you're going to be doing island cutting, and we'll come back to that at the very end, what you want to do is to get either a single-sided or a double-sided copper-clad board. These are made by MC Chemical, and I think I bought these at Fry's. They were on sale, and I just couldn't pass up a buy. These are both double-sided. They're called Catalog 550. They also make a single-sided, well, that's double-sided. I guess I bought a lot of that because here it is. Single-sided copper-clad board. Now you can do island cutting on this one as well. The advantage to the double-sided is not only do you have the ground plane on this side of the board, but you also have a ground side on the other side, which provides a much better impedance. And as you get higher in frequency, that becomes important. Okay, so what are some of the others? Well, unfortunately, Radio Shack is out of business now, but if you're lucky enough to have gotten in on some of their sales, you might have found some of these things. These are perf boards. They're not printed circuit boards. There's no copper on these. They're just phenolic perf boards. So on these, you run the wires through and then you hook them together on the other side. That is different from this kind of board. Well, now I've lost my example. Here it is. This board that has copper pads on the other side that you can solder to. It's sort of 6 of one and half a dozen of the other as to which one works better. It depends in part on the circuit that you're working with. And then there are a whole variety of other sizes, and once again, you can tell I really cleaned out the Radio Shack during their sale. This one is 2 PCBs. Here is a little bit larger type and larger still and so on, but you get the idea. Like I say, I kind of cleaned them out. I do a lot of prototyping. People used to accuse me of living in the lab, and they probably were right. At any rate, these sorts of things can be very useful when transferring from the prototyping board, the plug board, to a more permanent structure, or just build them from scratch on these kinds of boards. So I would like, though, to close by showing you how I drill the islands for the island cutter system. So let me show you that, and then we'll try to close out this too long video. Here is the system that I use for drilling the islands. You remember, or the islands, we're talking about these little circles on the copper-clad board. And this is an old drill press stand that probably I bought 35, 40 years ago. It's a Craftsman that you mount a drill, regular 1/4-inch drill in. Works pretty well. You really do need something that will hold the bit absolutely perpendicular to the board. Without that, you're going to find a frustrating experience if you try to use, for example, a Dremel tool. Now, they make drill presses for Dremel tools. I haven't tried those, but I understand that some people have good luck with it. But the important thing is, let me get down here so you can actually see the bit. And the thing you need to be careful of is when you put the board in here, you need something that will hold the board, and it helps actually if you use a clamp of some kind to hold the board down so it won't spin. And then you lower the bit onto the board. But it's very, very important that the board and the bit remain in the right configuration, because these bits tend to grab, and you'll if you're trying to hand hold a Dremel tool, you'll find it walks all over the place. So, well, the reason that I go into some of these things is if you're going to be ordering some parts to do some of this, it sometimes helps if you know ahead of time some extra things you'll need. So, for example, if you order some of these bits in a Dremel tool, think about trying to get a drill press for it. If you don't have a little drill press like this, they make some little tabletop versions that work pretty well that are just drill presses. At any rate, that's the way that I cut islands on boards. And frankly, if you get above about 4 or 5 megahertz, this is really the only way to prototype. Those little prototyping boards, the little punch boards, if you want to call them that, these in other words, I wouldn't use them much above a megahertz or two, certainly not above 5 megahertz. The capacity, and if you're interested in the details on this, there's a really good article or a good YouTube video by Dave Jones, the EEV blog guy, on the capacity, capacitance between these lines, and it will kill your high frequency response. So if you're going to go to high frequencies, I would go to island construction. In between the 1 to 2 megahertz here and the 10 or so megahertz and higher for this, you can use the PCBs. So that's my take on prototyping and how I do things. Just my opinions. I hope that some of them have been useful to you. And more importantly, I hope that it will get you to try a few things, because one of the things you will find is you don't learn electronics in a classroom, you just learn the theory. You learn electronics in the lab when you try to make the theory work. So, with that philosophical lecture out of the way, I will say I hope that you found something useful here and enjoyed the video. Look forward to some more, and have a very nice day.